Hello, my name is Savina Fuller from the School of Business and Public Administration. Our topic of research is the new age of educational robots, understanding the use of robotics in mathematics education.
Hello, my name is Chevell Parnell and I am from the College of Agriculture, Urban Sustainability and Environmental Science.
The outline of this presentation is motivation for research, introduction, literature review, empirical research, results and finding, discussion and implications. The motivation for research. Mathematics has always been a low point for students. The introductions of robots might be a way to help students learn. Robotics can reach a larger audience, for example, female and a lot of people from minorities. Robotics offer a rich multidisciplinary learning experience that touch upon several STEM disciplines, including electronics and computer programming. To broaden the representation in STEM disciplines, it is necessary to show students and teachers how they can make a difference and solve important problems. This will be shown when they understand the pros and cons of implementing robotics in mathematics education.
Artificial intelligence. The idea of deceased objects coming to life aged back to as far as 1952. The ancient Greeks had myths about robots, and Chinese and Egyptian engineers built automatons. The beginning of modern artificial intelligence can be traced to classical philosophers' attempt to describe human thinking as a symbolic system. However, the field of artificial intelligence wasn't officially founded until 1956 at a conference at Dartmouth College in Hanover, New Hampshire, where the term artificial intelligence was coined. The term artificial intelligence was first coined by John McCarthy in 1956. He held the first academic conference on the subject. Artificial intelligence works by merging large amounts of data with fast, interactive processing and intelligent algorithms, allowing the software to learn automatically from patterns or features in data. Cognitive computing is a subfield of artificial intelligence that strives for a natural human-like interaction with machines. Educational robots. There are 4 main categories of educational robots: physically coded robots, introductory programmable robots, computer programmable robots, and kit-based robots.
Physically coded robots. Physically coded robots use a physical means of coding instead of screens, toy-like in their physical design. These robots are perfect for introducing a few coding basics, such as sequence, through play-based learning to very young students. Introductory programmable robots. This introduced students in the early primary years to the idea of software and foundational coding concept in age-appropriate ways. The cute, toy-like exterior coding applications that feel like games and educational approaches that mix with play-based learning with progressive pathways. These robots strike a nice balance between just for fun and learning to code. Kit-based robots are ideal for students who already have an interest in and experience with robotics. High school students, clubs, electives, after-school programs, plus anyone looking to enter organized robot competitions, modular and flexible in their design. Students both build and use block-based or text-based coding applications to program these robots as they work through different project-based learning objectives. Computer programmable robots are computer programmable robots are purpose-built for teaching upper primary and middle school students core coding and computational thinking concepts through a mix of progressive lessons and standalone activities. Full assembled, these robots include a range of sensors and functionalities to enable more creative and complex coding using an on-screen block-based or text-based programming languages. Literature review. Robots in mathematics education is the implementations of programmed robots in the education system so that are capable of teaching mathematics, whether simple or complex, to students of all ages. Students have shown that students Studies have shown that there are benefits and positive outcomes associated with using robotics in mathematics education. All five of the sources use the robots to teach varying type of mathematics such as geometry, algebra, etc. Most of the results imply that for majority of the students, the robots plays an intensive role in them learning mathematics. The studies show no negatives of using robotic, robots in mathematics education. The trend in the literature as that there are advantages of using robots in mathematics education. However, both students and teachers need to have a positive attitude and be open to the advantages of using robots in mathematics education. The gap in the literature was that some students did not learn. There was no improvement in their learning outcome.
To collect data for this research, two forms of data collection was used: sample groups and observation. A sample group of 20 students were chosen and the groups were split into two halves of 10. Group A was taught using robots to teach maths such as algebra, geometry, mathematical constructs of other nature. Group B were taught normally using teachers. The groups were then given simple quizzes to test their understanding of the content being taught. Observation was used to document the engagement between both students and robots and the teachers and the students. The data was then used to determine whether the group with the most engagement had better learning outcomes. The results and findings are as follows. Research shows that when teachers have a positive attitude towards using robots in mathematics education, the students are more comfortable with learning from robots. Without teachers' acceptance, it is difficult for robotics to play an active role in mathematics education. 50% of the papers concluded that students have a positive attitude towards using robots for teaching mathematics, and of these, 40% noted that all teachers had a positive attitude towards using robots as an educational tool. Collected data shows that robots bring motivation and engagement into classroom, help students to build many mathematics-related skills, and have a positive influence on students' learning motivation. A research by Adams and Cook found that robots were more useful for short, simple tasks requiring reasonable operational skills. Lind and Holgerson concluded that the robotic tasks given to the pupils must be both relevant and realistic to solve. Regarding teachers' role, it is suggested that teachers motivate students, especially low-level students, to actively participate in the learning process. The results also found that students who engage more with robots have positive outcome, similar to those who engage with the teacher. The more amplified engagement is, the better the learning outcome. The discussions and implications are as follows. Based on the results garnered from the experiment, the pros of using robots in mathematical education outweighs the cons. The learning outcome when using the robots is mostly dependent on how open the students and the teachers are to using them in the education system. Research shows that when teachers have a positive attitude about using the robots, it is more likely that the students will use robots. When programmed, the robots will do exactly as programmed to. There is a reduced likelihood of misunderstanding. Additionally, the robots can be programmed to accommodate students with special needs. The more engaged with the robots the students are, the better their learning outcomes will be. Also, the more practice the students have with the robot, the better they will be taking advantage of its capabilities. Therefore, students need to interact with the robots frequently. Overall, there were no negative conclusions towards using educational robots in mathematics teaching. These are the references used to gather information for this research. Thank you for listening to our presentation. I am Chevell Parnell from the College of Agriculture, Urban Sustainability and Environmental Science.
And I'm Savian Colossi, Master's and Public Administration. Thank you.